two events, A1 and A2 in a sample space are mutually exclusive. Which Venn diagram correctly represented the situation? So what's events? What's mutual exclusive? Okay, let's go. Hi, my name is Dr. Kat. Um, in this lesson, you will be able to calculate the probability of two events to occur. So sorry, this is behind my camera. So let's start. Okay, so sets and probability. Alright, so this is called a Venn diagram where we can represent a sample space as one space, either in any shape. Usually we use a rectangle, and inside the sample space there will be some events, and these events is also represented by any shape that you like. So usually we just use a set of a circle. All right, so you can have, for example, here the sample space of even number, not event, even number from 2 to 50. That means the element of this example is from 2, 4, 6, 8 to 50. So these are the elements inside this sample space. Okay, let us define an event. The first event is any number from 0 to 10. That means you have 2, 4, 6, 8, 10 as an element. So this element is given by a criteria, so it can be inside an event A1. Okay, and then let's define another event where A2 is a number of factor 4. That's mean 4, 8, and it is going on. For the third event is any number larger than 40, which is 40, actually 40, 41. So let's make a correction here. So over that 50. Okay, so it's correct. Any number larger than 40, not inclusive 40. So this is 40, 44, 46, 40. Okay, so considering these three events, we can represent them with circle. So there will be some intersection. We call it intersection there. Okay, so these are the intersection 1 and intersection 2. Okay, so from here we can use the notation for set. For example, A1 or A2, that means even A1 and even A2. So it is what we call as a union. Union means A1 and A2, it has a 2, 5, 6, 8 until 48. That means it is a combination of event A1 and A2. So it is a union operation. We use operation union. Okay, and then if A1 and A2 is correct, that means the element which satisfy even A1 and even A2, we use it as this intersection. So the elements which fulfill this requirement only 4 and 8. Okay, so only 4 and 8 here, which satisfy the condition. So for not, that means other than A1. Okay, other than A1, that means any other than A1, we can write it as the bar on A1. That means this is not A1. All right. So if we carefully group them into their events, so you can have two area of intersections here. Right, intersections here. So from the picture, we can have the intersection between A1 and A3 is nothing. There is no element which satisfy the intersection which satisfy even 1 and even 3. Okay, so that set we call it as zero set here. So we can represent as this symbol. And then if we combine all sets, that means the element which satisfies all of them, actually it is represented as a simple space, because everything because it consists of all element inside the simple space. Alright, so if a1 a2, when we combine them, that means here, right? So anything which is not satisfy the condition of union A1 union A2, he left for only 42, 46, and 50. So this is the complement, or not A1 union A2. Alright, so two events are mutually exclusive if the event can occur together in a single trial. So that's we will see in the next slide. Okay, so all right. So two events are mutually exclusive if it is cannot occur together in the single trial. So for example, here you have a single space, a single sample space. You have an event A, and other than event A is called the not A, or complementary of A. So anything not in the A will occur in A bar. Alright, so for example, if the sample space contains all real numbers in the world, right? So all real number in the world. So when we pick something from the number, so it is either A even, event A is a even number, 2, 4, 5, 6. So out of that, of course, it should be odd numbers, right? So that means whenever you pick a point or pick a number, it can be either even number, which is A, or not even number, which is A bar, right? So that means the event of even number and odd number cannot cannot happen in one time, right? So that is what called cannot occur in a single trial. Or we can say that this A and B, A and A prime is having is a disjoint, have no elements in common. So that is what I said here. So set A and set A prime, there is no in common, so it is a zero set. Okay, zero set. And if we combine together, we get the sample space itself. All right. So remember, the merge two event which are mutually exclusive cannot happen together. So that is what we call mutually exclusive. Okay, so let's have axioms of probability. For every event A in a single space, the probability of having that event to occur is as follow. So that event must be, the probability of the occurrence of that event is between 0 and 1. Cannot be probability is -1. Cannot probability 1.2. So that is wrong. So the probability is must be 0 to 1. Okay. Then for the empty space or non-event and the sample space, so the probability of the sample space itself is equal to 1, and probability of a samples of an empty space set is equal to 0. Okay, so that satisfy the first one, right? Okay, for many we consider only two events, but if you have many of them, if you have many events occur in a sample space, so more than two, okay, so the union of each event which is available in that space, we can calculate the probability of that to occur as the probability of separate event to occur separately. So because they are mutually exclusive, so the probability of that event two or more event to occur, is the is the summation of the probability of each event to occur. Okay, so let's look at the example. Here, two dice are rolled out. What is the probability that a total score of 4 or 7 to occur? That means we have two event. Either it is we get 4 total or 7. So we can in this case we have two event uh, which occur mutually exclusive. Okay, because to have a first score, to have a first event, we must have the pair of the dice to be 1 3 2 2 3 1 to have 4 the table, and to have a score of 7, so you can have a pair of this event. So this uh, event A1 and event A2, they have no elements in common, so that's why we call it mutually exclusive. So from that, by our previous axioms, the probability for that two events to occur, the probability of that events A1 and A2 to occur is A1 union to A2, because they are mutually exclusive. It is just an addition of that individual probability of event to occur. So we can have this is 3 element over 36 possibility, and then the 6 elements over 36 possibility. So we add that up. So the probability to have either 4 or 7 as a total is 1 over 4, or 25% of the trial. Okay, for the probability of addition law, so before this we consider about mutually exclusive, but what is the two events are not mutually exclusive? That means they have something in common. They have some elements in common. Okay, for example, um, two dice are rolled. What is the probability that either sum is 8 or at least 5 appear? So that means to get 8, we can have possibility of among that at least 5 appear in one of the dice. Okay, so these are the probability, the 36 possibility to have the element of the space. Okay, so for the sum of 8 is this is the sum of 8. One sorry, what 8 or 6? Sorry, 5 6. Okay. This the red one. So 2 6 3 5. So the red one, the possibility of 5 of sum 8, and then the event for at least one is 5 is green. Okay. So let's have A1 is a sum of 8. So we have the sum of 8 is I have some mistake here. Okay. So it is so this is 5. Sorry, 5 over 36, because this 1 2 3 4 5. Okay, 5. And then at least 5 is 11, so you calculate the green. Okay, and then the what is in common, 2 over there are 2 in common, which is this one, and this common. Okay, so that is 2 over 36. Okay, and then the union of these events to occur is this plus this, but now you have to subtract this element, which is the intersection of A1 and A2. So this we can represent by this Venn diagram, where here you have actually these two elements inside the intersection. Okay, why we need to we have to subtract this, because it is counted twice. Okay, because you see it is counted twice. It is already in A1, it is already calculated in A1, and it is also calculated in A2. So we have to subtract the one of it. We have to put it out one certain the double count. Okay, so finally, so this is 5. Sorry, correct. So finally we get 7 over 18. So this is the event for the non-mutually exclusive. You have to subtract one element of intersection from the calculation, right? So let's go to the counting. So for there are two kind of order. We call it a permutation and combination. So permutation is a particular ordered selection, and combination is an unordered selection. So for example, how many two different letters P, Q, R can be made if a letter is not replaced? Okay, so you have P, Q, R. So when you take two letter from this PQR, you can have PQ, PR, QP, QR, RP, and RP. So this that means the first one P, and then next one should be Q, right? So these are the when you take and you don't take it back, you don't replace it. So these are the possibility. So this is called a permutation, because permutation is an ordered selection. You have to take one by one, so nothing left. Okay, so that is can be calculated by this relationship, and then you have n factorial and n minus r factorial. So what is factorial? Actually, for example, you have 3 factorial. Actually, 3 factorial is equal to 3 times 2 times 1. So until 1 you have to calculate. Okay. All right. So that is for the permutation. So you can calculate it is here is a three case, and then our selection is 2. So 3 divided by 2, so you have 3 divided by 1, so you have 3 to 1 over 1, so you have 3 possibility to pick the to have a pick in the 3 combination here. Okay, and then but if you take you take one and then you put it back, this means the set or remains 3 all the time. That means you don't replace it. You have to calculate in different way. That means this is not counted anymore, because it is just a repetition of because we don't care about the actually the order. So when we don't care about the order, so we only the remaining is PQ, because PQ is just equal to QP, right? Okay, so that is we have to calculate using this formula. It is just a permutation over the selection R. Okay, so from there actually you can get here 3 to 1. So your choice, your possibility remains to 3. Okay, so these are the important what we call characteristic of combination. So C and 0 equal to C and N, and this is equal to 1, and it can also be written as an R. Okay, next, lastly, let's return back to our teaser in the beginning. So you see this is a which one is the correct for mutually exclusive. So again, remember that the mutually exclusive means two events cannot occur simultaneously. So it will be in this, it's represented by this Venn diagram. Okay, so in the next lesson, we will calculate the probability with certain condition. Okay, see you then. Bye.